So I'll be talking a little bit about IntelliSuite 8.7, which is our software package, our MEMS-specific software package, and how it has possibility to help with teaching students and with research and with communication between different people in the department. But first, before I start talking about the software, I just want to give a little bit of an introduction to the company, our company Intellisense. We're a MEMS company based in Boston, and we were founded in 1991 as a spin-out from MIT. And we were founded with the original goal of developing MEMS-specific software tools, CAD and EDA tools that were specific to MEMS designers. And so the software has been under development for over 20 years now. And at this point, we're an industry leader in MEMS software tools. And we have a wide array of expertise, ranging from MEMS sensors and actuators to RF MEMS to optical MEMS, microfluidic and biomedical devices. Basically, over the years, we've worked on a lot of different MEMS devices and helped many companies and universities to develop and fabricate their designs. We have customers all around the world in over 30 countries, in North America and Europe and Asia. And these include many universities which are using the IntelliSuite software to help with their research and also in teaching their MEMS courses. We're working with lots of universities in North America as well as around the world internationally. And in addition to the universities, I'm going to cover more of the academic applications today, but we're also working with many of the top MEMS companies in the world in US and in Japan and Asia and in Europe as well. So that's a little bit of an introduction to Intellisense, the company. And what I'm going to do today is give you an introduction to the IntelliSuite software package and explain a little bit about the different parts of the package and how they can each help with MEMS development and with MEMS teaching. And so I'm going to go through some of the different parts of our software, including some of our behavioral modeling tools that you can use in the initial stages of the design exploration and optimization. I'm going to talk a little bit about the virtual fabrication tools, which you can use to develop a virtual model within the software. And I'll also talk a little bit about more simulation and meshing tools and some different simulations that can be done within IntelliSuite, as well as how the software can be used to help with designing the IC and the circuitry as well of the device. And throughout all that, I'm going to talk a little bit about how the software can be used to help with communication between different researchers and between different people working on a MEMS device, as well as how the software can benefit with teaching MEMS courses as well. So just as a little bit of an introduction, I'm sure you all know that MEMS design is highly interdisciplinary. Within a certain MEMS device, such as this vibromotor, for example, there's many different phenomena going on. There's mechanical phenomena going on, as well as maybe electrostatic actuation, different squeeze film damping or co-wet damping, as well as different contact physics and different damping and losses to various sources. So in short, a MEMS device is very complex, and there's a lot going on. And what we're really trying to do with the software is trying to help MEMS designers to be able to better simulate their devices and make things a little more simple for them. And that's really one goal of the MEMS-specific software tools that we've developed. And then the other goal is, or the other challenge within MEMS design is that it takes a lot of collaboration between many different people. So in industry, it might be between a device engineer and a process engineer and an electrical engineer. All have to be communicating. They all have to communicate with the system architect and the program manager. And this is sometimes referred to the chain of pain in the industry setting. Here I've documented, it might not be quite as bad within the academic setting, but you still have to have communication between the students that are working on the project, and the professor needs to communicate with the department chair and the people who are working in the labs. And so it's a challenge to be able to be communicating between all these different people. And then the other challenge is just finding a convenient way to be teaching MEMS concepts to maybe undergraduate students or graduate students who have no experience in MEMS. And what we can also do is help with that process, and I'll talk a little bit more about that later. So to start off, I'll talk a little bit about the behavioral modeling tools. And this is something that can be used in the initial stages of the design cycle of a MEMS device. So this would probably be more applicable to research that's being done and a device being developed rather than teaching MEMS courses. But within the research, this might be a good tool to use initially. And what this simulator is, it's called Simple within our IntelliSuite package. If you've ever used an electrical circuit simulator and known what it's like to wire up a schematic using different transistors and resistors, and you'll be wiring up a circuit, connecting them all together and running a simulation. That's kind of what this simulator is similar to. Within our simulator, Simple, you'll be having these different pieces of a MEMS device, like a plate or a beam or a comb drive, and you can use those elements and connect them together to build up a MEMS device, such as a resonator, and then you can run a simulation on it. And the advantage of doing it within the schematic-based simulator like this, as opposed to maybe like a finite element simulator, is that this is a good thing you can use initially because it's very easy to make changes to the design and to do some parametric analysis and do a lot of optimization initially. So you can see on the left side of the screen is a bandpass filter device that's been built up within our schematic-based simulator Simple. And so you can kind of get an idea that different beams and anchors and plates and comb drives elements are connected together. And you can see on the right is what the device actually looks like. Within the simulator, it gives you the option of viewing the results in 3D and viewing the model in 3D to see what it actually looks like. And like I said, the advantage of this tool is that simulations, these behavioral type simulations can run very quickly, for example, in just a few minutes, whereas within a full finite element simulation, if you needed to do, say, a full dynamic simulation, it might take several hours to run the simulation. And even though this is a much faster simulation, the accuracy is still very good. Usually within 5% or so accuracy of the full finite element simulation. And so this is a good thing to use initially to get kind of narrow down your design and get a rough idea of what you want your design to be. And then you can go, after you take this step, then you can go and do some more full finite element simulation and really nail down the specifics of the device. And like I said, the other thing in this, the advantage of this tool is the possibility to look at different process variation and how that will affect the device behavior, and do some parametric analysis. So say you want to vary the dimensions of the structure, vary the thickness, vary the material properties over a certain range. You can do that, run that simulation very quickly. Once you've built up the device using the simulator and explored your design a little bit, what you can do is you can export a mask layout. So once you build up the schematic with these beams and plates and things, you'll see that you can export to a mask layout, and it will include all of the different stress relief features and etch compensation features that you can add. And this is just a way to save time if you're building up a device within this tool. Saves you the time of having to draw it all up within the mask layout editor. What you can also do is go ahead and export automatically. You can export a mesh to go ahead and do some finite element analysis. And this is something that you can do using our automated meshing tools, which I will talk a little bit more about later on. The benefits of using the simulator simple is that you can save a lot of time. The simulations run much more quickly than within a full finite element simulation. So like I said, this is a good thing to use in the initial stages of the design cycle when you're doing some design exploration and optimization. So you can explore multiple designs very quickly. And the automated mask and mesh export make it very easy to transition on to the next stages of the design cycle. So the next thing I'm going to talk about is some of the virtual fabrication tools, which are very useful for developing a MEMS device as well as using for teaching MEMS courses. And so what you can do with these virtual fabrication tools is build up a virtual process traveler within the software. So we have a process library included with the software. You could also potentially add your own process steps in there. And from this process library, you see that you can build up a process traveler. And this tool is a good way to, when you're building up a process for the MEMS device, maybe you need to be debugging the process. This is also a good way to be teaching students about MEMS fabrication. And you can have the students maybe build up a simple process flow and then see what it looks like through the virtual fabrication tools. So you'll see here that you can watch the structure being built up layer by layer. So you can see the materials being deposited, and you can see the materials being etched away based on the mask layout that you link in with the process flow. And then what you can also do is look at cross-sections of the device. You can see this is kind of a cross-section here, but you can go ahead and look at cross-sections and see what's actually going on inside the device. And as well, if this tool is being used in the development of a MEMS device in a research project, once you build up the model in this way, you can also export it using our automatic mesher and create a meshed model, which you can then go ahead and use to do some simulation on. And now, something new within our latest version of the software, IntelliSuite 8.7, is our new virtual fabrication tool called FabSim. And what this tool is it includes full physical simulation of each of these process steps. What's Then the standard before in the MEMS industry is more of a process emulation, where the user actually has to input what the geometrical parameters are and basically tell the software how to visualize the structure. But within our new tool FabSim, we have full physical simulation, so you can actually put in the process parameters. Say if you're doing a wet anisotropic etch of silicon, you can put in, say, the temperature and the concentration of KOH that you have, and you can put in how long you're doing the etch for, and put in the mask layout. And based on all those process parameters, it's going to run the full physical simulation and actually show you what the final geometry of the structure is going to look like based on those process parameters. And this is something that's really never been done before in the MEMS industry. Having this full virtual fabrication tool where you can build up the entire MEMS device and going through all the process steps, and also having that with the actual physical simulation. So you can see kind of in the top picture here, this is an anisotropic etch, and it will show you all of the undercutting behavior that you're going to see. If, say, you're doing a dry etch, a DRIE etch, you're going to see the different phenomena like the etch lag. So you'll see the smaller hole in the bottom picture on the right is not going to be etched as deeply as the larger hole. You'll see things like scalloping when you're doing a dry etch lag, things like that. So this is a useful way to teach students about how MEMS processing is actually working, the behavior of, say, an anisotropic etch and the behavior of a dry etch, and everything that goes into that, as well as predicting accurate models when researchers are developing their own devices. Once you build up a process traveler within the software, you can export it, in this case, to an Excel file, which you can then take and go ahead and use in the clean room, possibly make notes on and share with the different people in the clean room. You can also automatically generate a PowerPoint file, and this is a good thing that you can use for presentations, for also sharing the information between maybe the professors and the students and the other people in the department and people in the clean room, people in the lab. And this PowerPoint file will get generated automatically and show you, have a slide for each step in the process and show you how the device looks at that step. In addition, included with the software are different process design kits for standard processes, standard MEMS processes, say like the MUMS process from MEMSCAP or the Sandia Summit process. And these process flows, and also we have design rule checking decks which are included. These are all included with the software for the different processes, and the user just needs to input the mask layout that they're using and link that in, and they will be able to look at a 3D visualization of the model very quickly. We have a MEMS-specific layout tool as well called Blueprint, which includes a lot of functionality that's very specific for MEMS designers, such as, in this case, different filleting drawing tools and things like that. And it's also very easy to, say, import like GDS formats or DXF formats into the software, because many researchers are already using other layout tools. It's very easy to import layout formats, as well as import and export 3D model formats, standard 3D solid models like IGES and SAT files, standard mesh files from different 3D meshing formats. And we can also export, I'll talk a little bit later, we can export to various system level simulators as well. But we've made it very easy to import and export models in and out of IntelliSuite and interface with other software programs that you might be using already. One neat thing that you can do within the layout editor is link it with the process flow that you built up, so you can quickly look at 2D cross-sections if you might be developing your mask layout and designing your mask layout and you want to see how it's going to look when it's actually being processed. And we also have a lot of other capability, which I won't touch on today, but things like design rule checking and scripting and other functionality that's very helpful for MEMS development. Going back to the process simulation tools, we also have some more advanced simulation tools. If you want to be looking at, say, in this case, wet etching specifically, you can see this is an example of a microneedle array that was simulated within our tool called IntelliSuite, and that's the blue models you see on the bottom, and those are compared to the FEM pictures on top. And these etch simulators are very advanced and can be looking at multiple steps within the etches, within multiple mask layers, and you can really simulate some very complex structures. And like I said before, see how see how changing the etch recipe might affect the final geometry. We have a large etch rate database which is included in the software, and the software can also be calibrated to the user's etch rates very easily. And all of the etch simulation tools have been benchmarked very rigorously with different experiments. You'll see this is another example here. So they have very, very high accuracy, and just kind of a very, very unique and powerful tool that we've developed within IntelliSuite. One other new tool within IntelliSuite version 8.7, in addition to some advancements with the etch tools, the etch simulators, also in the new version is a new tool called Exposure, which is a lithography simulator for deep resist, thick resist lithography. And this is something that you can look at things like exposure and post-exposure bake and development. And so this is one new process simulation tool that's included in the latest version. And as I mentioned before, we also have some dry etch simulation tools where users can look at RIE and look at DRIE and look at different phenomena like etch lag and scalloping, and modifying how the different dry etch parameters will be affecting the final geometry of the structures. And as I said before, this is, all of these tools might be good ways to help out researchers that are developing the process for their device and figuring out how to manufacture the device. Or they could be used to teach students about the intricacies of, say, silicon etching, silicon wet etching, or dry etching, and how changes in process parameters will affect the etch. So that's a little bit about the process simulation tools and the virtual fabrication tools. What I'll talk a little bit now is a little bit about the multiphysics tools, which Many of you are probably familiar with different finite element tools, such as ANSYS or COMSOL or things like that. Within IntelliSuite, within our multiphysics simulator, we've made a lot of developments that are very specific for MEMS and very helpful for MEMS designers. So I just want to talk a little bit about how those might be used. Now, one thing that we found in working with customers over the years is that meshing models was a big problem for many designers. And trying to create an accurate mesh and one that didn't cause problems in the simulation was a task that was very time-consuming. And so we've really tried to help out a lot with this in developing various automated meshing algorithms. And so we have different automatic meshers so that no matter where in IntelliSuite you're developing your model, say you just want to import the layout for your model that you've already developed and input what the thicknesses of the different layers are going to be, you can automatically mesh a model that way. If you're developing a process traveler within the virtual fabrication tool and you develop a 3D model that way, you can export and automatically generate a mesh. And also, if you're using the behavioral simulator simple, the schematic-based simulator, you can automatically mesh a structure that way. Basically, we've tried to make it very easy to create meshes and meshes that are accurate and robust, and also will have the most likelihood of simulation convergence, as well as have the maximum simulation speed, but also the best accuracy. Within our simulator, we also have a coupled finite element and boundary element method. And this really helps to increase the accuracy of the simulations, specifically for MEMS devices, as well as speed up the simulation time. And the basic principle behind this is that it's a coupled mechanical mesh coupled with a separate mesh, separate electrostatic mesh using the boundary element method. And the advantage of this is like I said, it's much more efficient and has a much greater ease of convergence, because these things like internal air gaps and things don't need to be meshed, and the air gaps, for example, don't need to be remeshed as the simulation is running. And it also makes it much easier to deal with issues such as contact and post-contact, which is very important for different types of MEMS devices like RF switches. Within our latest version, IntelliSuite 8.7, we have a lot of capability for multi-contact models. So models that are have contact in multiple different places. You know, some very complex situations which our simulator is able to handle. And like I said, this coupled finite element boundary element method has a lot of accuracy advantages and speed advantages versus just a pure finite element simulator, such as ANSYS or COMSOL or something like that. The simulator is fully coupled with thermal, electrostatic, mechanical, piezoelectric, piezoresistive capabilities, as well as fluidic and fluid structure interaction, and some electromagnetic capabilities. And we've worked with many different companies and universities on different types of MEMS devices, ranging from inertial sensors to different RF switches and filters, different optical devices, as well as microfluidic devices. So we have a lot of experience in developing and simulating a wide range of MEMS devices, and these tools can be useful for researchers that are developing devices of their own, as well as many of the universities that are using IntelliSuite for teaching courses. Many of the professors, they have their students build up simple devices within the software, maybe a simple RF switch or a simple comb drive, and they teach the students how the device is built up, and they have the students run, some simple natural frequency simulations, maybe to look at the different resonant modes of the device, and they have them run some simple simulations to look at the device behavior. And we make this phase very easy within IntelliSuite because we have many tutorials that are included with the software, which outline step-by-step how the students can build up these models and simulate them and get results from them quickly. And here's just a few examples of some of the different microfluidic phenomena that we can also simulate with the software. Different things like electrophoresis and dielectrophoresis, pumping applications, fluid structure interactions, different electrokinetic phenomena, fluid flow, different things like that. The final thing that can be done within the software is that the MEMS device can be integrated with the control circuitry, because that's a very, very important part of the design cycle as well. And one thing that's important after you develop the MEMS device is to take into consideration how packaging effects are going to be affecting the device behavior, as well as how the interactions with the ASIC are going to be affecting the behavior. And so this is something that we can also help with within the software. The main way that we can help with this within IntelliSuite is once you have your 3D model, say this Tang resonator that we had looked at earlier, what we can do is we can do a system model extraction. And so basically from that finite element model, we can extract a reduced order model, which can be used in a system level simulator, say maybe like SPICE or Simulink or Cadence or other different types of system level circuit simulators. And so we can export that MEMS model, so then the MEMS model can be put as sort of this black box element into the system level circuit, and the circuitry can be wired up around it. And the way this is done is that the mechanical and electrostatic energy within the device is calculated, as well as the fluid damping characteristics, and a reduced order model is created, which we like to say is an n degree of freedom model. So it will include all of the higher order effects and all of the second order effects. It will include all of the behavior of the MEMS device. Basically, these models, we've benchmarked them to be very accurate in comparison with the full model, within 1% usually. And this is something that's very unique within IntelliSuite, because really there's no other tool out there that can generate these types of models with this high level of accuracy, with these n degree of freedom capability, and including the higher order effects and the second order effects. There's other tools that might be able to do kind of more of simplified models in this case, but not really having the full behavior of the MEMS device, and being able to export these models, like I said, maybe to VHDL or Verilog or SPICE, Simulink, any kind of different system level tool. So just in going through the whole design flow, like I mentioned, first you have the design exploration and the optimization, which can be done within the behavior modeling tool, Simple. We have the once you do that, you can export the mask or the mesh, like I said, maybe do some final design within the multiphysics simulator. Also kind of an offshoot, there's also going to be the process development and the process simulation that's all done within there as well, as far as the final mask layout design. You can then export the reduced order model, like I mentioned, and go ahead and do the transistor level, circuit level design in some different EDA tools. And then you eventually be going ahead and developing the final layout. So as kind of a summary, as I mentioned before, MEMS design is a challenge in many aspects. It's a challenge in that MEMS devices are very complex, and there's many different phenomena going on at one time. And it's also a challenge in collaboration between the, say the different engineers that are working on different parts of the project. Maybe in the case of a university setting, it's different students are working on different parts of the project. One student specializes more in process. One is more a device design. One specializes more in some other part of it. And they all have to be communicating between themselves and within the people in the clean room staff, as well as with the professors and the different people within the lab group. And there's also a lot of challenges within the academic setting within teaching students about MEMS and teaching students about the unique properties of MEMS, the unique fabrication methods of MEMS, the unique phenomena of, say, silicon etching and wet etching and dry etching, and just how MEMS devices are fabricated within the different deposition steps and etching steps. And really just, kind of communicating how MEMS devices are designed and built in the real world. And so what we're really trying to help with within the IntelliSuite package is helping with all those challenges and making them all easier. And some of the different tools we can use to help with that, as I talked about, are the different initial behavior modeling, schematic-based tools for design exploration, the virtual fabrication tools that can save a lot of time and save a lot of costs within a research project setting, and also make it much easier for students to get a grasp on the MEMS fabrication process when used for teaching. The different automated meshing algorithms and different things like the coupled finite element and boundary element simulator help to speed up the design cycle, help to make it easier for students to get an accurate mesh and to get a simulation that runs quickly. And we can also help to develop different extraction methods that help to link the MEMS device with the system level circuit as well. And so really to sum it all up, IntelliSuite is a very powerful package that we've been developing for over 20 years, like I mentioned. Intellisense was founded with the original goal of providing MEMS-specific software tools to the MEMS industry. And we're working with many MEMS companies around the world right now, many of the top MEMS companies. But we also like to work with universities. We have a university partnership program which gives heavily discounted pricing to universities to help them incorporate the software in their research work, and incorporate, say, classroom licenses within a classroom setting for teaching MEMS courses. And we have universities all around the world, all around North America and Europe and Asia, which are already using IntelliSuite to help with research and teaching. And so really, the advantage of IntelliSuite for universities is that the students are able to get some experience with this industry standard tool, and get the experience of what it's actually like using a tool that's used within the MEMS industry, so that they can gain some experience and see what it's really like to work as an engineer using these tools in the industry. Or maybe, say, if they're just learning about MEMS, these tools make it much easier to look at things like the MEMS fabrication and different process simulation and different things like that. So that's a little bit of an overview to IntelliSuite and to some of the different functionalities that are included within the software, and some different ways to go ahead and use the software for MEMS research and teaching. And so I thank you all very much for attending this webinar today, and really appreciate you all taking the time to learn a little bit more about IntelliSuite. So at this point, I'll go ahead and look and see that we might have a few questions that I'll go ahead and answer.
Okay, so now we are open to question and answer session, and you can, if you want to ask a question, you can go ahead and type your questions in Q&A box within the WebEx window, and we'll get back to you and answer your questions.
Mm-hmm. Yeah, so I see one question that if someone would like to design and optimize and fabricate an accelerometer, and they wanted to know about different steps within the software package that can be used. And so for someone designing an accelerometer, this is something we have a lot of experience with. We've worked with many companies to help them design accelerometers. If you're just getting started with the software and you want to know how it might be used, we have many tutorials that are included with the software that show you specifically how an accelerometer or a gyro might be used step by step. And so these are a good way to get you started within seeing how the accelerometer is going to be developed. But basically, like I said, it's going to be going through the whole design flow within the software. You could maybe start out within Simple, which is the behavioral modeling schematic-based tool. You can go ahead and use that tool to to link up the different elements like the beams and the plates and see how they might be used. And you can kind of initially explore your design that way. From there, what you can do is you can maybe say export the mask layout that you're going to be using. You can automatically generate the 3D model, and from there you can do some further analysis. Maybe look at the different resonant modes of the accelerometer. Look at exactly the accelerometer behavior and how it's going to behave under different conditions. At the same time, you can also be developing the process flow for the device. And from there, if you want to, you can export the accelerometer to a reduced order model, which can then be used with a different system level simulator. And so that's kind of the entire process where you might go through the development of an accelerometer within IntelliSuite. One other question is what might IntelliSuite's advantages be compared with different tools out there in the industry, different MEMS-specific tools or different standard tools. Like I said, the advantage of IntelliSuite over just kind of a simple finite element package, such as maybe ANSYS or COMSOL or something, is that within IntelliSuite we have the whole design, the whole design cycle included within IntelliSuite. So we have all of the fabrication tools and the process simulation tools and the mask layout and the design exploration and the system level reduced order model export. And so everything is included within the suite, and the whole design cycle can be simulated. And so that's one advantage of IntelliSuite over a simple kind of finite element or multiphysics simulator. And as far as advantages compared with other, maybe similar MEMS-specific software packages, is that IntelliSuite, we've always been a company of MEMS designers. So we, in addition to developing software tools, we have experience ourselves in developing MEMS devices and actually doing fabrication of MEMS devices. We had our own clean room for a long time. So really, we're MEMS engineers. We're MEMS engineers rather than just software engineers. We have experience developing MEMS devices ourselves, and so we know what MEMS designers need, and we know what tools are useful for them, and we tailor our tools to be useful for them. We also had a lot of unique capability, like I mentioned, within the FabSim, which is full physical process simulation. And so you can actually look at how the process parameters are going to affect the final geometry of the structure. And this is especially important within silicon wet etching, and we can also do quartz etching. We can also simulate dry etching as well. And all of these capabilities are really unique to IntelliSuite. And we also have some unique capabilities within simulation as well, as I mentioned, things like the n degree of freedom reduced order models and the different types of, say, microfluidic simulation. We have capabilities for that's very unique to IntelliSuite. We have a very strong capabilities for coupled coupled simulation, coupled multiphysics simulation. And finally, we really care about supporting our customers, and we feel that our level of customer support is the best in the industry. We're always very willing to help users with their devices, help users with their designs, and if users they want to see us add some capability within the software, we're very happy to take suggestions and work with users to add new capability to help users, help make it easier for users to design and simulate their MEMS devices. And so I think that's about all the time that we have for questions right now. So I guess I'll turn it back over to you, Pranay. If you see if we have any other questions, I'm happy to take them. Otherwise,
sure.
I'll turn it back over to you.
So, as mentioned, if any of you have further questions, you can write to me, and my email address will be visible to all of you in the chat. And I'll try to get your questions answered from Mr. Johnson. I would like to take this opportunity to thank Mr. Johnson for agreeing to hold this webinar. And with this, we end our webinar session. And so please watch out in future. We'll be having more webinars like this. And so we request you to join them whenever they are going to come up. Thank you, Mr. Johnson. Thank you, everyone.